Here's problem 431. A satellite's in a circular orbit 600 kilometers above the Earth's surface. The acceleration of gravity is 8.21 meters per second squared at this altitude. The radius of the Earth is 6,400 kilometers. Determine the speed of the satellite and the time to complete one orbit around the Earth. Well, if we had an Earth and we had the radius of the Earth, this satellite is some distance h above the Earth, going in orbit at that radius. So here's the location of this satellite. And so the true radius of the orbit of the satellite is equal to the radius of the Earth plus the height that it is above the Earth. And that's going to be 6,400 kilometers plus 600 kilometers, which would be 7,000 kilometers, or 7 times 10 to the 6 meters will be the radius of this orbit. Now, if we did a free body diagram of this satellite, we would find that the only force keeping it in the circle and supplying the centripetal acceleration is the gravity force. That's called mg prime. So it's true that mg prime is equal to the mass times acceleration for the satellite. And in other words, then g prime is equal to the centripetal acceleration of the satellite. So g prime is actually equal to v squared over r. So we should have that the velocity is equal to g prime times r square root. In this case, that's going to be equal to 8.21 times 7 times 10 to the 6, all that square root, and that's equal to 7,581 meters per second. Thought I needed more room, so that's why I was conserving. So we also want to find the time that it takes to complete one orbit. Well, if we're going around this circle like this, the circumference is going to be equal to 2 pi r, and hence our velocity times the time will equal the circumference. So the time for one orbit is going to equal the circumference divided by the velocity. 2 pi r divided by our velocity, which would be 2 pi times 7 times 10 to the 6, divided by the velocity we just found, 7,581 meters per second, and that's equal to 5,802 seconds. So it'll take 5,802 seconds to complete one revolution, which would be 96.7 minutes, about a little bit more than an hour and a half, which is probably around what the shuttle generally does. So 5,802 seconds for the period, velocity 7,581 meters per second.